This is the question from the paper 2023, right? This is of May June 2023. Now see what they have said. If a silicon diode, सबसे पहले तो you know कि एक diode current का question है. So for that you should know the formula based on that, right? So what is the formula of diode current? ID is equal to I naught e raised power Vd divided by eta Vt minus 1. So Vt is how much? That is temperature. Vt is the temperature related to this. Vt formula is T divided by 11600. ठीक है. Vd is the applied bias voltage, diode voltage basically. I naught is the reverse saturation current. Id is the diode current. Okay. So we'll have fixed value for eta. Eta is equal to 1 for germanium and eta is equal to 2 for silicon. So silicon they have given, so that's why eta value is 2. And they said reverse saturation current of 10 nanoampere. Reverse saturation current is I naught, that is how much they have given? 10 nanoampere. 10 nanoampere means 10 into 10 raised power minus 9, correct? Now they have given the temperature in Celsius. We need to convert temperature in Kelvin because this temperature formula is in Kelvin. So add 273 plus 27, that would be how much? 300 Kelvin. So now we know eta, we know this one, we know Vt, that is 300 divided by 11600. Now they said calculate the yeah, they said calculate the reverse current. Now see diode voltage. Vd is the diode voltage. And what is the diode voltage? They have mentioned that is 0.7. So this thing is also known. So after solving, can we get the diode current? Tell me, solve it and then tell me the value. Okay, so after solving, we'll get this value of ID. तो ID पता है. Now they are asking the reverse saturation current. ठीक है. Again you have to use the same formula. ये value use कर लो. I naught this time we need to calculate, right? Vd same रहेगा, that is 0.7. Eta is same, silicon. Vt same, temperature same है. तो अब ये वाली value use करके can you get the value for I naught? Now again the same question papers 2023 May June. This is the question of rectifier. 4 marks का question है. They said peak value Vi is equal to 20 sine of 2 pi 50 t. तो standard equation क्या होती है हमारे पास? We'll have V is equal to V max sine omega t, right? So if I'll compare it with this, omega is 2 pi 50, right? So frequency is 50 and V max is how much? 20. They said it is a full wave rectifier if the load resistance means RL is equal to 1 kilo ohm. Same question है तुम्हारा in B descriptive notes. I told one student in the morning. Exactly same value, same question. Okay? Yeah, same question. So follow for that, follow B descriptive notes for your paper. Okay, I'll send it to you. So I average is how much? 2 I max by pi. IRMS is how much? I max by root 2, right? I max, now tell me how can we get the value for I max? Because if we know the value of I max, then we can get the value for average and we can get the value for RMS as well. Now you tell me how can we get I max? Now see, in this case we need to calculate I max, correct? So according to Ohm's law, V is equal to IR. I would be V by R. V is 20. RL is 1 kilo means 1000. So it would be how much? That is 0.02, right? Ampere is the current. So we can substitute the value of I max. This is I max, and then we can get I average and IRMS. Correct? Understood? Now see, after that we need to calculate the efficiency. What is the formula for the efficiency? Efficiency is output power divided by input power, right? And you know efficiency, a power formula is I square R, or we can use V square by R, correct? So if I'll use V square by R, V square by R, now output is in the form of DC or AC? Tell me. Output is in the form of DC or AC? What is the function of rectifier? It converts AC to DC. So output DC, input is AC. So we can say that VDC divided by RL. Similarly for AC, we'll write down VRMS, right? So RL से RL cancel. It would be V square DC divided by VRMS. Correct? So we can substitute the value, or we can use I square DC into RL divided by I square RMS into RL, right? So RL से RL cancel, IDC we know, IRMS we know. IDC is I average only. Clear? After solving, you will get 81.2%, and after solving IRMS, I average, you will get as 12.73 milliampere, okay, and IRMS you will get it as 14.142 milliampere. Now they are asking for the ripple factor. Ripple factor is denoted by gamma, and its formula is IDC over IAC. Okay, again you can substitute the value, then you will get the answer. Next, they can ask you the frequency also, because they'll generally ask you the frequency. So output frequency, write down, in case of full wave rectifier is twice multiplied by the input frequency, but output frequency will be equal to input frequency in case of half wave rectifier, and this is for full wave rectifier. ये formula तो एक बार. Again, this is also the question from 2023 May June, and this question is also from that same PDF. 3 marks का question है based on the rectifier. They said a particular load must be supplied with 10 milliampere, right? So basically load is connected with the DC side, right? So basically they have given IDC is equal to 10 milliampere. Now they said average current, that is IDC, is 10 milliampere at 5 volt DC supply. So basically VDC is 5 volt. The ripple factor is not more than 10%. So we can consider ripple factor is 10%. 10% means 10 by 100, that would be 0.1. Calculate the value of filter capacitor, means we need to calculate the value of capacitor, right? That needs to be connected to the output of the full wave rectifier, and they have given frequency is equal to 50 hertz, right? So we'll have formula for that, that is R is equal to 1 divided by 4 root 3 F C R L. F is the frequency, C is for capacitor, RL is for the load resistance. So now R is given, right? Capacitor we need to calculate, frequency is also given, but we don't have RL. Now we need RL, correct? So RL is how much according to Ohm's law? V by I. So it would be VDC divided by IDC. VDC is given, IDC is also given. You can convert it into the standard unit. After solving, we'll get RL is equal to 500 ohm, right? So we can substitute the value of RL over here, then we'll get C. Milliampere is 5 milliampere is how much? 5 into 10 raised to power minus 3. 10 milliampere is how much? 10 into 10 raised to power minus 3. 10 microampere is how much? 10 into 10 raised to power minus 6, like that. This is your answer for the capacitor. Okay. This is also the question of 2023 paper, same paper, 3 marks का. सबसे पहले तो you need to draw a circuit. Okay. So circuit is like this. I told you that it is the same standard circuit for all the cases of Zener diode. Then they said label all components. This is load resistance RL. This is series resistance RS. This is supply voltage. This is VZ. Total current IS. Zener current IZ and load current IL. Okay. Now they said the Zener diode in a circuit regulator has a breakdown voltage of 15 volt, right? So basically VZ is how much? 15 volt with the power rating. Power rating means PZ is equal to 0.5. If the input voltage is applied is 40 volt, means supply voltage is 40 volt. What is the minimum value of the series resistance? Means we need to calculate the value for RS, right? That prevents the Zener diode from the being destroyed. Now you tell me how can we do it? इसमें हमारे पास they have given VZ, so consider VZ is equal to VL, right? So after that you should know the formula of RS, right? RS का formula. So what is the formula for RS, which I told you earlier also? That is 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 equal to VS minus VL divided by RS. Correct? So we should know IS, we should know VS, and we should know VL. VS is how much? 40 volt, right? VL is how much? 15 volt, because VZ is equal to VL. Now we should know IS. How can we get IS? By the formula IS is equal to IZ plus IL, right? IS we don't know. IZ is how much? Power is given. Power is equal to V into I. PZ is equal to VZ into IZ. So IZ is how much? That is, we need to calculate VZ is 50, power is 0.5. So we can get IZ, right? But we don't know IL also. IL we need to calculate. IL we can get it by VL by RL. RL also they didn't mention. So we can calculate. Now see 40 volt is the supply voltage. 15 volt इसने ले ली. So how much is the left voltage? 25 volt. So इसके across voltage is 25 volt. So 25 है. So now we can put here as 25 by RS. So VS पता है, VL पता है. Now we are left with one variable. See in this, if we want to convert it into XS3 code, सबसे पहले we need to convert the number 3 is 0011 1248 1 2 plus 1 into 1 3. Okay, so existing number is 0110. Add it with X 0 0 1 1. Answer is 1. 1 plus 1 0. 1 carry. 1 plus 1 0. 1 carry 1. Its answer is 1 0. Okay. Now we need to convert it into the gray code. How to convert it into the gray code? It's 0 1 1 0. We need to convert it into the gray code. So what is the value? So we'll write down as it is, right? So its final answer is 0 1 0 1. Do you know how it came? 0 is as it is. 0 plus 1 is how much? 1. 1 plus 1 is how much? 1 plus 0 is how much? 1. Okay. The answer, yeah, carry will be ignored. Now next one is odd parity Hamming code. ये एक बार छोड़. Next one is this, obtain this by using one's complement. So now see, this is also question from 2023 K-map का question है. Okay, this is for don't care. 0 1 10 11 12 15, right? 4 8 14, 4 8 and 14, right? Now you need to make the pair. It is green wala is bar d bar, according to, yeah, interchange also you can do it, and yellow wala is a bar 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 a bar b bar d. Okay, and blue wala is a bar b bar and c bar is common. Blue wala is bar, so and this one is your answer. This is also the question from 2023 for binary data. This one, they said the sketch the ASK, FSK and PSK signal, right? So we need to draw the first binary data. As you know, 1 stands for above and 0 stands for down. So it would be 1 0, then sorry, it's times 0. So it would be 1, right? Then 0, then 0, then 1 and then 1, correct? This is the binary data they have given. So extend it like this. Always is kind of way of presentation. Then next you need to draw the carrier signal also. They didn't mention, but you have to draw the carrier signal as well. Okay, as you know, carrier signal is like this. This one is the carrier signal, right? Now you need to draw the ASK. ASK stands for amplitude shift king, correct? So ASK, wherever you got 1, then that means it is normal. This is ASK, and wherever you got 0, the output is also okay. Then again you got 1, then the it is similar to the carrier. Understood? This is the waveform for ASK. Next they are asking to draw for FSK, right? So I'm drawing here for FSK. If it is 1, same, we'll draw the carrier signal. But as you know, FSK stands for frequency shift king, correct? So frequency in the 0 k, if we'll give input as a 0, so frequency like time increases and frequency decreases. So in this case, it takes lot of time to complete one cycle, right? So it is like this. Then again 1 1, so normal according to the same as carrier signal, it is FSK, correct? Now next one is PSK. As you know, PSK stands for phase shift keying, correct? So if I'll draw for PSK, then it would be like this. Phase, there is a change in phase, so it is one, the normal according to the carrier signal. Okay, now 0 0, you don't need to mention anything. Now phase changes, see it's end at positive, now the new cycle will start from the negative. Okay, same as the carrier signal, correct? So this is for FSK. Understood? This question they have given for 3 marks for the 3 waveform. Note it down. Now see this question. This is a question based on FM. They have given us the frequency like voltage signal. Voltage is equal to 10 sine 2 pi 10 raised to power 8 t plus 5 sine 2 pi 15,000 t. Determine the modulation index. First they have asked. So what is basically the modulation index? Modulation index is denoted by M, right? They ask you the modulating frequency. Modulating frequency is denoted by FM. They ask you the frequency deviation. Frequency deviation is the delta F. Got it? So basically, if you know the formulas, the formula for the delta F is how much? Beta multiplied by FM, or we can say modulation index. Modulation index is divided by M multiplied by FM. Okay, understood? Clear? So we should know M and FM. What is FM? FM is the modulating frequency, and FM they have given the modulating frequency is 15,000 hertz. So FM we can say directly say it's a 15,000 hertz, or we can say simply 15 kilo. Okay. And what is FC? FC is the carrier frequency. FC is how much? That is 10 raised to power 8 hertz. Okay, clear this thing? So what is the formula for the modulation? That is FC by FM. So can you solve it? We'll have FC and we'll have FM. After this we'll get modulation index. We'll get M value, we'll have FM. Now if we'll substitute in the formula M and FM, then we'll get change in frequency also. Correct? Now see, it's a easy question or not? Right? It down. Now see the next question that is based on amplitude modulation. They said a 250 watt. So basically they have given the power. If I'll tell you the formula for the power, that is P equal to PC into 1 plus M square by 2, where PT is the total power which they have asked. Now they said 100 kilohertz carrier. 100 kilohertz carrier means it's a carrier frequency modulation to a depth of 75%. So modulation is 75%. 75 by 100, it would be 0.75. Okay, understood? We know modulation, don't know PC. Modulating signal of 1 kilohertz determine the total power transmitted in sideband thing. So basically power is also given for the carrier case, that is 2. It would be 1 plus 0.75 by 2 ka whole square. This is the case for the PT. PT is the total power, right? Understood? Now see what they have given. Fc is equal to 100 kilohertz, and modulating signal frequency is they have given as 1 kilohertz. So if we want to calculate the upper sideband frequencies, that is Fc plus Fm, and if we want to calculate LSB, means lower sideband frequency, that would be Fc minus Fm. Okay, these are the formulas. Based on this, you must need to remember. Now see in this question, an audio frequency signal 10 sine 2 pi 500 t volt is used to this one. So basically frequency signal is this one, carrier signal is this one. ठीक है, दो टाइप्स के सिग्नल होते हैं, one is carrier signal and one is modulating signal. So this one is the modulating signal which we need to modify, and this one is the carrier signal, correct? Now they are asking the modulation index. As you know, the modulation index formula is AM divided by AC. AM is the amplitude of the modulating signal and AC is the amplitude of the carrier signal, right? Now can you tell me what is the amplitude of the modulating signal? As I told you, this is the equation for the modulating signal, right? So this 10 is the amplitude for the modulating signal. Similarly, 50 is the amplitude of the carrier signal. Clear? So it would be 1 by 5. Next, they are asking the bandwidth required for transmission. Bandwidth formula is twice multiplied by FM. So 2 into frequency of the modulating signal. How much is the frequency of the modulating signal? As I told you, this one is the modulating signal. So 2 into 500, that is 1000 is the bandwidth hertz, correct? Now they are asking the sideband frequencies. Sideband frequencies means USB and LSB. USB stands for upper sideband, that is Fc plus Fm, and LSB stands for Fc minus Fm, that is low sideband frequencies. Now you tell me this value. So Fc is carrier frequency is 10 raised to power 5 and modulating frequency is 500 hertz. Put it down the value, then you will get the answer. It's a very important question. Okay, like all these questions are from the last chapter, from the previous year paper, and these are very important questions. Remember it, correct? Note it down. So next question based on AM is define amplitude modulation. वो तुम कर लेना. Now this said sketch the spectrum of the AM signal. Now this said a certain AM transmitter radiates 9 kilowatt. Okay, so they are talking about the with the carrier, means they are talking about the carrier power. Carrier power is how much? 9 kilowatt, and 10.125 of the power when it is modulated, means this is the total power. They have given 10.125 kilowatt. You just need to calculate the modulation index. Remember I told you the formula, PT is equal to PC into 1 plus m square by 2, correct? So PT we know, PC we know, we can easily get the modulation index. Simple. And this is of 4 marks question, so easy, right?